In this video, we are going to take the text that we extracted with vision language models from PDF documents. This is what we have done in the previous video. But if you don't have PDF documents, feel free to extract text from Word documents, text documents, or even websites if you want. The most important thing is that we need to have text because we will take that text and divide it into chunks. How do we divide text into chunks? You might have heard about something called RAG, which stands for Retrieval-Augmented Generation. In this system, you divide the text programmatically into chunks that have the same size. Let's say that you have this text. Programmatically means that you will decide to divide this text into, let's say, chunks that have 200 characters, or let's say by paragraph, or something like that. This is not a good idea because we risk losing context between chunks. In this example, the first chunk that I colored here in this light blue color ended before the end of the sentence. You can see that here it ended in this word hybrid, and the second chunk starts in the middle of that sentence. This can happen because documents can be big and you cannot control where you stop. What we should do instead is analyze the text and divide it into chunks that talk about one thing. In this example, we can store this text as one chunk because it describes a figure. This first paragraph describes the figure, and after that it tries to tell you the numbers that are inside that figure. So this can be stored into one chunk because it talks about the same thing. There is no need to divide this into multiple chunks. But how do we do that? There is no way we can achieve something like this just by writing code. But we have some options that we can try. The first one is to divide the text manually. This approach is slow and boring. The second idea, on the other hand, consists of using large language models. This method is way faster and will get you very close to the final result. The rest is on you. You need to supervise the output from the model to ensure that it can be used. Here is the flow that we are going to follow in this episode. First, you take the input text. This is what you need to extract from any document. It can be PDF, Word, text, it doesn't matter. We just need raw text. We give that text to a large language model and we ask it in the system prompt to divide the text into chunks that focus on one idea. After that, you take the extracted chunks that the model gave you, and finally you judge that output. If the chunk is good, you keep it. But if you think that some chunks can be merged, do it. If you want to delete chunks, do it. Because at this stage, the model has done a good job. It gave you all those chunks very quickly, and now you can go through those chunks without spending a lot of time. If we wanted to do this manually, it will take you ages to convert all those documents into chunks. Luckily, we have large language models. They will help us tremendously in this task, and we just need to supervise the output. Enough theory. Now open VS Code and let's start coding. Before I start showing you the code inside the second notebook, I want to mention that I have made some changes to the previous notebook. Before, we had just one notebook, but I decided to divide it into how many notebooks? 5. So that we simplify things. So if you want to run just Gemini, go into that notebook and run it instead of running every single cell in order to get to that section that you want. So I think this way it will be easier for you to get the specific section that you need. And I have also added another model. We have NanoNet's OCR2. This model has just dropped recently and I tried it and it gave me very good results and I decided to add it. This model is bigger than Granite Dockling. Granite Dockling has 258 million parameters, but nanonets comes in two versions. The first one has 1.5 billion parameters, but here I decided to use the 3 billion version. Using this model is easy. You just install the transformers library, and there is no need to run llama.cpp or any other library. And I think I might keep adding models. If I see that we have models that are very performant, I might add notebooks in this folder. Keep an eye on this. And now let's start with the second notebook. So here again, I have divided that into two sections. Here we have Gemini, if you want to run the proprietary model. And here we have Gemma 3. This is a language model. And here I didn't want to add more because there are a lot of language models that we can choose, and you decide the model that you want to run locally. So let's start with Gemini. As I said, we will take the text that we extracted from the previous step, and here the task is easy. We just need to write a system prompt that we will give to the LLM in order to teach it how to divide the text into chunks. Here is my system prompt, but if you want, you can change it. There is no problem in doing that. I have decided to divide this into different portions. So first I try to describe the task. This is the output format that I want the model to use when outputting the chunks. And after that, I try to add examples to show the model how to perform this task. You can read this. I will not try to read this to you, but when you download the code, you can read it yourself. But this is the first step. We need to create the system prompt. Now I will run this cell, and here I have a way to count the number of tokens. This comes from the generative AI package. Let's see how we use that. But first, let's load the text that we extracted. So here I have done this behind the scenes just to prepare this for the second notebook, and you can find this text inside the extracted text folder. So if you open the data folder, you'll have everything here. So I'll try to store the extracted texts here so that you can run the notebook without any issue. And here I have added, so here, this is the document that we worked with previously, the scanned PDF document. And here I added the original one, which is unscanned, and it contains, I think, 110 pages or something like that. So that's why we have 85,000 characters. So this is the one that I am using. So now let's count the number of tokens. Luckily, it's simple. So here you call the count tokens method and you provide the model. So here, because we are using Gemini 2.5 Pro, this is what we are going to use. If you want to experiment with Flash, change the name here. And after running this cell, let's see what we get. So we have 8,000 tokens in the prompt and 18,000 tokens in the text. So in total, the number of tokens that we will send as input is 26,000 tokens. Why am I showing this? This is very important, especially if you want to run models locally, because when you increase the input, you will need a lot of memory. Just keep this in mind. But here, since we are using Gemini, there is no problem because we are going to run, this query will be executed in Google's servers. And now we are going to create a Pydantic object. A Pydantic object is going to be used by Gemini to force it to output a valid JSON. As you can see, each chunk in our JSON output will have just one field, the text chunk. And this is similar to what I have mentioned in the system prompts. Let me go back to the system prompt just to show you where I have added that. It's here. So in the output format, you can see that each object contains one field, the text chunk. And this is what I have created here in this Pydantic class. We have just a base model that contains one field, and I call this text chunk. Let's run this cell. Now we are ready. So we have the prompt, we have the extracted text. Now we have everything to start extracting the chunks. And here, this is where we are going to use that class. So here in the generative AI package, we have the ability to specify that the output should be a JSON, and because we will receive multiple chunks, we want the output to be a list of these classes, of this class. So every object in this list will have just one field, the text chunk. And the max output token, I have set it to the max value, 65,000, just in case. Okay, now we can run this and let's wait for it. The request took almost 3 minutes. The time will vary depending on the size of the text. Here, as you saw, I am working with a very big document. That's why this request took 3 minutes. But if you are working with small documents, it shouldn't take that long. We have access to this parsed attribute. The great thing about this is that it will parse the output and give us Pydantic objects. So let's run this. As you can see, the number of chunks have changed because the models are not deterministic. Each time they will give you something different. And here, these are Pydantic objects, so I can look at them. Let's take the first chunk. And as you can see, it has just one field. So now I can do this and get the text chunk. Why is this better than, let's say, not using Pydantic objects? From the response, we can, instead of getting parse, we can get text. And this is what we will get. Now we need to do that parsing by ourselves. That can work, but sometimes the models might fail to output a valid JSON. But luckily, Google have this implementation that guarantees that the output will be a valid JSON. Okay, so we got 63 chunks. Now let's look at the number of tokens that the model has generated. So you see the input number of tokens is 26,000 and the output we have almost 20,000 tokens. So in total we have 46,000 tokens. So that's a lot. So keep in mind that if you want to use this locally, you need to have a lot of VRAM in order to handle this amount of tokens. As I have mentioned, we can get the text by accessing the text chunk attribute from each class. Here I am looking at the first chunk, and here if you don't remember, let me show you the document. So it's rog strix. Let's look at the unscanned. Let me put it here and let me go to the first page. You can see this is the cover page, and here the model extracted this text and it stopped. That makes sense because this is the text that we have in the first page. After that, we have the table of contents, etc. And here 10, I think, let me look at it. So it's battery safety information. Okay, so it's in this page. So it took the title, the subtitle, it took everything, frequently charging, it took the notes, etc. It also took this part because all of these things talk about the battery safety information. And then it stopped right here. So let's verify that. Yes, leakage that may cause fire. That may cause fire. So that makes sense. So the model took all these parts. In some scenarios, maybe the model will take this as a chunk and this as another chunk. And you'll decide if you are fine with that output or if you want to merge them both, like what has the model done here. Okay, so it seems to be working. And now we have our chunks. Let's see what we will do with them. Now we need to save them. Okay, and here we are going to add an ID. I'm going to explain this in the upcoming video. So basically, in the upcoming video, we are going to generate question pairs, question answer pairs. And for each question, we will have a chunk that will answer it. And in order to link them together, we need to have an ID, a way to identify a chunk. And this is how we are going to do it. We already have the text chunk, but let's also add the ID. So now if I run this and look at text chunks dictionary, let's look at the first one. As you can see, so this is the text and this is the ID. So we will do this just to prepare for the next video. And now we can save it inside the chunks folder. I have already done that. So if I open the chunks folder, this is what I get. So these are all the chunks that we will save for each document, and later we will merge them together into one big file. So let me close this one. I don't want to save it because I don't want to push those changes. And now let's open the open source model. Here I chose Gemma 3 and I am using one of the smallest models, the 4 billion model. Like before, let me show you the steps one more time. So you go to Hugging Face. For example, here I am looking at the model in the ggml.org repository. You go to files and here you choose a quantization level. This choice depends on the amount of resources that you have. So you can go with Q4 or Q8 or F16. This is a this is a multimodal model, which means that it can process both text and images. And for these types of models, you'll have two types of files that you need to download. You will need to download the mmproj file for the vision capability and one of the other models for the language model. So here you click on this one to download the mmproj and choose one of these. If I go back to VS Code, you will see that this is what I have mentioned in this text. So for example, here I chose Q4 and the mmproj file. And after that, you start the llama-server with this command. If you don't want to use Gemma 3, but you want to use, let's say, Qwen or other models that only process text, you can do that. And those are simpler because you will download just one file. Let's look at Qwen as an example. Okay, here is Qwen 3. I can click on it. Let's look at this, the 4 billion one. Let's look at files. And as you can see, there is no mmproj file. You need to download just one file because this model does not have the ability to process images. Let me also run the server in the terminal. Here, this will not work for me because I need to change the name of the models. Let me do that quickly and I will come back. I am back and I have changed just the name of the files. Now I can run this. Here, make sure to change the number of GPU layers. Here, this model is small, so I chose 999, but if you are working with bigger models, change that so that you don't get an out of memory error. Okay, so now it says listening on this port. Okay, that's good. Now we can go back to the code and let's start. I took the same system prompt from the previous notebook. Here, we cannot use we can use the generative AI library to count the number of tokens, but every single model has a different tokenizer. So we need to use the tokenizer that comes with the model. And luckily with llama.cpp, they have the tokenized endpoint, which will take the text and tokenize it. So if I run this, you can see that here we are using the same port, 36912. You can change this, set it to any port. And after that, so we tokenize the prompt and we get the length. So this gives us 26,000 tokens in input, which is a lot, which is similar to what we got with the Gemini tokenizer. And now I have modified this function slightly so that we can stream the output. I have added this because running these models on my hardware, it's a bit hard. Even though the Gemma 4 billion model is small, it's still not fast. I'm getting 20 tokens per second. It's decent, but it's not the best. As you can see, so the generation is great, but since we have a lot of text, that will take minutes. But let me show you what we have here. So I have also added a user prompt, which basically tells the model that I want you to carefully split the document into coherent chunks. So yeah, basically you can read this. And I have stated that I want only JSON array. And I am using the same text from that document that contains 110 pages. And the problem that I'm facing with Gemma 3 is that, look, it finished. It says that it finished in 34 seconds. But if I look at the output, and another problem here is that we cannot use Pydantic objects. So we will need to parse this ourselves. So that's not a problem, we can do that. But if we count the number of chunks, we will see that we have 1, 2, 3. So here's the table of content, and then it will stop. So I have tried to basically play with the prompts, but I couldn't get this small Gemma 3 model to do this task for me. So the only thing that you can try is to use this model with small documents. Here, I didn't want to, let's say, take 10 pages, feed them to the model and get the chunks, because we will lose that context. For example, with Gemini, I wanted to give it the document and let it decide how to divide it. With this small model, I couldn't do it. But I have tried the Qwen, the 30 billion model. That one worked very well. But the problem, the generation speed was way slower. I was getting 5 tokens per second or something like that. So if I wanted to wait for this for this model to finish chunking this document, that will take hours. But at least I've tried to write this notebook for you. If you have more GPUs than I have, then in your case it will work very well. But in my case, I couldn't rely on these open source models because I don't have the right hardware to run them on. But yeah, this is the idea, and hopefully you understood how we divide the text into chunks. But as I said in the slides, there is one more step that you need to do. You need to verify the output. So you need to verify if these chunks are correct. Do you need to merge chunks together? Do you need to delete some chunks? You decide. So yeah, this is the last step that you need to perform, and this should be done manually. We will not ask the model to do that for us because the models are stochastic, and here we are not going to try to generate millions of chunks or millions of question-answer pairs. We will just generate maybe 500 or 1,000 maximum. And yes, this is going to take a few days of work. I have done this at my current job, but in the end, you will get a high quality data set. It's way better than giving the LLMs to do all these tasks for you. That's it for this video. See you in the next one.